An ordinal variable is a type of data that represents categories with a meaningful order, but without a fixed numerical difference between them. These variables indicate ranking or relative position, but do not show precise distances between values. For example, in a satisfaction survey with options like very unsatisfied, unsatisfied, neutral, satisfied, and very satisfied, the responses have a logical order, but the difference between each level is not equal. Ordinal variables are commonly used in social sciences, education, and customer feedback to measure subjective opinions or performance levels. Now let's look at some examples of ordinal variables. One example of an ordinal variable is a ranking system in a competition. If athletes finish a race in first, second, and third place, the ranking shows their relative performance, but the time difference between each position is not indicated. The difference between first and second place could be a fraction of a second, while the gap between second and third could be several seconds. Another example is an education level classification, such as elementary school, high school, bachelor's degree, and master's degree. These categories follow in order, but the difference in knowledge or years of study between each level is not always consistent. Now let's look at some strengths of ordinal variables. One strength of ordinal variables is that they provide a clear ranking system, making it easy to compare different categories. Even if the exact numerical differences are unknown, ordinal data helps classify items in a meaningful way, which is useful in decision-making and analysis. Another strength is that ordinal variables are flexible and widely used in research. Many surveys and studies use ordinal scales to measure attitudes, preferences, and performance, allowing researchers to analyze trends without needing precise numerical values. Now let's look at some weaknesses of ordinal variables. One weakness of ordinal variables is that they do not provide exact differences between categories. Since the spacing between values is unknown, it is difficult to calculate averages or apply advanced mathematical operations, limiting their usefulness in statistical analysis. Another weakness is that ordinal data can be subjective. People may interpret ranking categories differently, leading to inconsistent responses. For example, one person's definition of satisfied in a survey may be different from another person's, making it harder to ensure accuracy in the results. Now let's look at an alternative to ordinal variables. An alternative to ordinal variables is interval variables, which not only have an ordered structure, but also have equal differences between values. For example, temperature measured in degrees Celsius or Fahrenheit is an interval variable because the difference between each degree is the same, allowing for more precise calculations. Unlike ordinal variables, interval data can be used for advanced statistical analysis, making it useful when exact measurements are needed. However, interval variables require a consistent measurement scale, which is not always available in subjective ranking systems.